In this video, we are going to be looking at balancing equations. And so first thing is we want to do is discuss about the law of conservation of mass. So the law of conservation of mass tells us that mass is neither created nor destroyed. And so by balancing a chemical equation, what we typically do is we follow that law. And so we can't end with more or less than what we started. So if we start with 100 grams of substance, we need to make sure that we are ending with 100 grams of products. And so balancing the equations helps to ensure that. Now, before I get into any of the details, I want to just discuss, what a chemical reaction is, what are the different parts to a reaction. And so the first thing you always start with are the reactants. And the reactants are going to yield towards the products. And so the reactants and products all have differing physical states just depending on the reaction. So you can have a solid, you can have a liquid, you can have a gas, and then finally you have AQ, which stands for aqueous, and typically aqueous is a solution that's formed. And most of your reactions are going to be aqueous based for the most part in your chemistry 1. So in terms of balancing the equations, we need to make sure we know what the correct formulas are for the reactants and the products, and then we're able to go about solving for the balancing. Now, this is just a 15 different examples of different equations that you can work through balancing. So we're going to work through a few of these in this video. So the first one that we're going to work out is nitrogen gas reacting with hydrogen gas to form ammonia. Now, what I typically do is I look at the left side and the right side, and I bring down the elements. So there's 2 elements on the left and the right. There's nitrogen, and then there's hydrogen. So on the left side, I have 2 nitrogens and 2 hydrogens. On the right side, I have 1 nitrogen and 3 hydrogens. So right off the bat, I can see that I'm not balanced. I don't have the right number of nitrogens, and I don't have the right number of hydrogens. Now, what we can do is we look on the right-hand side, and we say, okay, we can balance the nitrogens by putting a 2 in front of the NH3. Now, you put the 2 in front of the NH3, what you're doing is you are going to use distributive property, and so that gives you 2 nitrogens, and it also gives you 6 hydrogens. Now, that takes care of the nitrogen. Our hydrogens are still not balanced, but when we look at the left side, we have 2 hydrogens, so a common number is 6, and so we put a 3 in front of that H2, and so that gives you 6. Now, making sure that you're balanced, we have 2 nitrogens and 6 hydrogens. Now, the blank spaces in front of the N2, if you don't like that, just put N2. But if you don't put anything, it typically just means that there's just 1 nitrogen there. So, but, we have 1 nitrogen, 3 hydrogens, and 2 NH3s, and this balances the equation out. So that's as simple as it can get, because all you're doing is just breaking it down, looking at the different elements. Now, this reaction has 3 different elements. It has potassium, chlorine, and oxygen. So I like to split it off left to right, and I write them in the same order so that way I can easily see what I'm looking at. So you have 1 potassium, 1 chlorine, and 3 oxygens on the left. On the right, you have 1 potassium, 1 chlorine, and 2 oxygens. Now, right off the bat, I see the potassiums and chlorines are balanced, but the oxygens are not. So the 3 and 2, common number would be 6. So let's put a 2 in front of the KClO3. That gives me 2 potassiums, 2 chlorines, and 6 oxygens. Now we're going to put a 3 in front of the O2 because we want that to be 6. Now at the same time, what we did is we now have to rebalance our potassiums and chlorines. So we're going to put a 2 in front of the potassium and in front of the chlorine. That gives me 2 of each of those. So that balances the equation out. So the order that I go through is going to be slightly different from what you can do. This is a puzzle. You start with whichever element you want to start with, and that's how you go about solving for it. It's not like I'm telling you here. You got to start with oxygen, then you do potassium, you do chlorine. You could have started with the potassium chlorine and went to the oxygen, but as you saw the way I did it, potassium chlorine was already balanced. The oxygen was not balanced, so I balanced out the oxygen. Then I have to rebalance potassium chlorine. That's why I did it that way. Now, we look at another one here. So this problem, we have sodium, chlorine, and fluorine. So we have one sodium on the left, one chlorine, and two fluorines. On the right, we have one sodium, one fluorine, and two chlorines. So we can see that the sodiums are balanced, but the chlorine and fluorines are not. So let's take care of the fluorine. So you have two fluorines on the left and one fluorine on the right. So let's put a 2 in front of NaF. Now that gives me 2 NAs and that gives me 2 Fs. So we balanced out our fluorines naturally. Now the sodium, on the other hand, is now not balanced. So we're going to put a 2 in front of the sodium chloride. That gives you 2 sodiums and it also gives you 2 chlorines. That balances the equation out, and so we're done. Again, any blank spaces, you can put a 1 or leave it blank if you want. Now, the last one we have to look at, we are going to be looking at a combustion reaction. Now, a combustion reaction is where we take a hydrocarbon reacting with oxygen, and that produces CO2 and water. So we have 3 elements. You have carbon, hydrogen, and oxygen. So you have 8 carbons, 18 hydrogens, 2 oxygens, 1 carbon, 2 hydrogens, and 3 oxygens. You might be saying, how do I get 3? You have O2 plus an O, so that makes it 3. Now, one thing you want to make a note of is on the left side, there's 2 oxygens. Anything you multiply there is going to be times 2, so it's going to be an even number. So you always want to make sure that the right-hand side has an even number of oxygens, so that way you do not have any issues showing up. So now I'm going to go ahead and start with just the most basic thing here, and I could do 8 carbons here, and I have 18 hydrogens, so I'm going to put 9. So right off the bat, what I see is a problem here, and this is something that comes with experience, is I see that when I have the 9 waters, but that's going to give me 9 oxygens. So that's going to give me an odd number. So we don't want to do that. So what I will do is I'll bump it up. So I'll go up 2 more. So I'm going to put 2 in front of C8H18. That gives me 16 carbons. I'm going to put a 16 in front of that. 2 times 18 is 36. So we need 36 hydrogens. So 18 times 2 gives me 36. So that balances out that. That gives you 16 carbons. But 16 times 1 gives you 16. Now we look at our oxygen. So we have 16 times 2, which is 32, plus 18. So that's going to give you 50 oxygens. Now we can work with that because that's an even number. So what times 2 gives you 50? 25. So we put 25 there, and now we have our 50 total oxygen. So we have 16, 36, and 50. So that's how we work combustion reactions. That's the way I do it. Again, you can learn it a different way, but in the end, what's most important is that the equation is balanced and you have equal number of atoms on opposite sides. So going back to this worksheet that you see here, there's a lot of different problems. I would suggest you work these problems. And so one problem I will point out to you is number 5. So you see how you have an OH group here? If you look on the right hand side, there's not an OH group because it's hidden. Now we have H2O, but H2O can also be rewritten as HOH. And so that's perfectly fine to do that because it helps you to balance it. Now if you look on the left, you have 2 OHs. On the right, you only have 1. You put a 2 in front of that, now you have balanced your OHs, and it gives you 2 hydrogens. So it gives you 2 hydrogens, so you're going to put a 2 in front of the HCl on the left side. Now that gives you 2 Cls. You look on the right side, you already have 2 Cls, 1 lead. So that's the easiest way to balance a problem that you come into contact like that. So anytime you find hydroxide, you can turn it into a much easier problem by taking the water and writing it as HOH, and that way you can physically see the hydroxide. Now looking at number 10, we see that we have an OH on the left and we have an OH on the right, so we don't have to worry about doing any pulling out or rewriting of a formula. So this one is straightforward. So if you look at that, when you have 3 OHs on the right, you have 1 OH on the left, put a 3 in front of the NaOH, that balances out the hydroxides. Now that also changes the sodiums to 3, so I'd put a 3 over here. And so now it gives you 3 Na's and 3 Cl's. If I look at the left side, I've got 1 Fe, which your ions are balanced, and your Cl's are now 3, so that balances the equation out. So 1, 3, 1, 3. Looking at number 11 here, all right, we have phosphorus plus oxygen gas yielding P2O5. Now I look at the oxygens first because the phosphorus is easy to balance out. It's the oxygens that's going to be the challenging part, which it really isn't. So 5 and 2, common number is 10, so we're going to put a 2 in front of that, put a 5 in front of the oxygen. And so looking back at the phosphorus, you have 2 times 2 is 4, so we're going to put a 4 right there. That balances that out. All right, so what I'm gonna do here is I'm gonna stop at this part. I want you guys to finish this up. If you have any questions, leave me a comment, or you are free to email me, whichever. Thanks for watching.